Around when we do that. Okay, so we were talking about planned processes. The idea is that if we want to understand what processes are taking place in the factory, then we look at the plan or the specification. And we are going to try and keep the ontology economical, so we don't want to have different types in the ontology for every combination of processes. So the idea is this: we have a drill. The drill is going to be drilling holes in plates. The drill is going to, according to the plan, the drill is going to be drilling holes which are identical holes in the sense that they are holes which are instances of the very same type of hole, and the type of hole is determined by the specification. This is the simplest case.
Yes, the simple case.
We'll have to think about a more complicated case. And now the planned process, or the process plan, tells us what kinds of holes we're going to be drilling. And then when we execute that plan, we have a series of instances of acts of drilling a hole.
Yes.
The machine and the plate and the drill bit and so forth, they tell us what the participants in the process are.
Yeah, but I just extended it.
Yeah.
But by modification of this example, we can drill 15 holes in one plate,
yeah,
which is different scenario from one where we drill 15 holes in 15 plates.
Right. And now what I want to say is that in the ontology, we have two terms. We have act of drilling a hole, and then we have operation. And if we drill one hole in 15 plates, then we have 15 operations. Now, this is not necessarily the way the plan will specify it, but the plan will specify in some way, the schedule. We'll assume that the word operation is used. In the other case, we have one operation which consists of drilling 15 holes in one plate, and then we don't need anything more in the ontology other than operation and act of hole drilling. The operation is determined by the process plan. What is an operation?
No, operation is determined by a plate. If you have one plate, you have one operation.
Yeah, but
15 plates. Yeah. But that's important. Operation is defined on a particular part or product on a plate. So if you have 15 plates,
okay,
15 operations.
Then I don't even need that to be specified in the process plan. It's already specified by the rule according to which if you have acts, manufacturing acts of drilling, for instance, applied to the same part, workpiece.
Yes, same, yeah, plate. Call it plate.
Okay, applied to the same plate, then it's the same operation. And if you have the act, the manufacturing act applied to different plates, then it's different operations.
So but we are doing, plate as a product that we are making defines how do we define operation. So we say operation is something that is done on a given plate or product. But is that done on one machine? So if you have two machines on the same plate, I mean, we do have to expand it because this is too simple for reality. Yeah, so after this plate, after drilling goes into, let's take heat treatment, completely different process.
Yes. So
there are two operations.
The idea is if we're going to build the ontology, we have to start simple.
I know.
And we have to work out questions like this.
If we keep simple cases only, then we are going to miss important points.
Yeah. And so we have to see.
I agree with that.
We have to see how we can deal with complicated cases without having a combinatorial explosion in the ontology itself. The ontology should be kept as small as possible in order to provide a vehicle for interoperability, for instance, between different...
I can define a rule that we said operation is something, set of processes that happens on a same plate.
Okay, now that in itself...
On a single machine.
On a single machine. And now let's suppose you have a machine which can do multitasking. It can drill holes and it can paint.
Yes.
And is that one operation?
So,
or let's suppose the same machine is drilling holes on all the plates on day one and then painting all the plates on day two. Is that one operation or is it? drilling holes. It's drilling all the holes in
These are
one plate
two
on day
operations.
one and doing painting on the same plate on day two.
These are two operations because of two different contents. You have to
So
paint
it's
them
not just the
with
machine.
the same specification.
It's not just the machine and the plate. It's also the contents of the.
Yes.
It's the kind of act.
Yes.
Either it's
Kind
an
of
act
right.
of
Yeah,
drilling or it's
painting
an
or
act
drilling.
of painting.
Painting or drilling.
Okay,
Yes.
good. Okay, so we can define operation.
Yes.
Okay, so we have a way of determining what the operations are in terms, for the case of the hole drilling on a plate, in terms of the single act of drilling, together with the definition of the operation, which is specified by the rule that you just formulated.
Yeah.
Okay,
And
so
the content of work also, drilling and painting are two different.
Yeah.
So they cannot be one operation, could be a different operation.
Okay, so we can go home.
I'm painting.
We're done.
You want to talk about this one?
Well, that's, you have to force me to talk about the more difficult case.
Yeah. I mean, simple case is good to understand fundamentals, principles.
Yeah.
But then from the single case, we have to build what is happening in reality. I mean, just digression.
So give it to me.
Just digression. So in assembly lines for cars, I don't know if you want to go in details. There is a workstation which is actually listed as a car body is moving by conveyor on very slow speed. Let me see, maybe a couple of yards per minute. And on the given workstation, which is actually, I was in Toyota in Japan. I just want to see this is recording. I want to have this. They have a 9 stages about 10 feet. And there are 2 or 3 operators putting different parts into that assembly. And so I would consider that this...
and these are human operators?
Human operators.
So why don't they use robots?
It's complicated. It's inside. They use robots for welding. So since these 2 operators work together, so you can consider each of them single operation or 2 of them same operation because they work on the same space. And they have several tasks to finish. So this is what I want to, hopefully, that we can go out and describe. We have a finite definition of describing using ontology.
So given your example, my temptation would be to say that the operation here is the installation of the part into the assembly. And that is one operation.
That doesn't correspond to, I mean...
Your example.
I know. But in the example with plates, we said there are different operations because they happen on different parts. But in case of assembly, we are not making parts. We are making car body. We are just putting parts into assembly. We are making part body.
Yes, I don't see any radical difference.
It's a big difference. The result of...
No, I mean, ontologically speaking, I don't see why we need to have a new ontological infrastructure to deal with the difference in assembly and removal, which is what the drilling is. So we have an active drilling and we have an active assembly, or an active installation of parts.
In act of drilling, we make, let's take back example, 1 plate with 15 holes. We are making one operation in which on a given plate we make 15 holes. Now that plate goes into assembly, and we put 15 bolts or screws on each of these holes on that same part. So why is this in one case 1 operation, in second case is 15 operations? If you say that in assembly, each operation belongs to each of these bolts.
So if we had a robot with 15 arms, and in each arm there is a single bolt, then the placing of the bolts into the holes would be 1 operation.
Are we mixing process and plant process and operation? Is operation also plant process?
So we're only, when we're dealing with cases like this, we're only talking about what is planned. If we try to talk about what is not planned, we will have an
So
infinite.
is the operation subclass of planned process? With criterion being that result of operation is one.
You gave the criteria. So the job of the ontologist, at least my job, as an ontologist who is particularly interested in the easy questions which arise at the very top, but somewhat easy, is not to lay down the rules as to what counts as an operation. You just gave some rules, which I was perfectly happy with.
Yes, I'm happy too.
And so it's up to you to determine what is one operation. My job may be to determine what is one manufacturing act, or act of manufacturing, act of milling, act of drilling, and so forth. And what I'm principally concerned to establish at the moment is that it is possible to avoid a combinatorial explosion by recognizing how individual acts of drilling form operations. It may be that there are other ways in which we can avoid a combinatorial explosion. We have to avoid.
I am for avoiding combinatorial explosion.
Good.
I'm not talking about that. So you are trying to tell me if there are 15 holes, there are 15 factorial ways to build them. Is that where you say a factorial explosion? So 15 factorial different sequences.
Okay, so my vision goes something like this. We have act of drilling a hole. There are many different kinds of hole. It may be that we need an ontology of different kinds of hole, but I'm hoping that we can cope by just having features, qualities. So whether a hole is horizontal or vertical in a plate, for instance.
That same process. We don't want to have different process types for this one and this one.
Okay,
so this is same process.
Okay, but we need to do justice to the fact that in some cases the hole is pointing along one axis of a part. In other cases, it's pointing along another axis of a part.
Yes.
So we need to distinguish different features of holes, but not different kinds of holes necessarily. We will need different kinds of holes. Holes which are, for instance, tunnels which run all the way through, and holes which are just rigid. Which are just
blind and
yeah.
Okay. Yeah, we need to do that, but I think I agree with you that if hole is horizontal or vertical, we are still making with the same, with the given. Otherwise, okay, so other specification be the same.
Consider the case you were talking about earlier. So I will present this case.
A little bit. Let's see if we can. There's light.
Yeah. Yeah. It's not great for some reason, but no, that's bad. What you just did there is bad. That's better. Let's leave it there.
Because I saw it.
Yeah, on the screen it's not very good. Maybe. Maybe.
Shall I just try to remember what I wrote 10 minutes ago?
Yeah.
So we said here there is one part which has one slot and one hole.
Okay.
The second part which has different slot and different hole.
Okay. Now, before you go any further, the parts are both instances of the same type when we begin the process. The way you've drawn them.
I can do something different. They're not same.
All right. Okay.
I don't want to make them instances of the same type. I mean, I know they start with the same block.
Okay.
But they have to be different.
Okay. So the slots then are instances of the same type.
Yes. And holes are instances of the same type.
Yes. The holes are instances of the same.
Yes.
However, the holes are located the holes are located differently in relation to the respective parts.
They actually, yeah, that's true. They have same, okay. Question is, what is specification? So I would say that these holes have same specification. So hole specification is here, 1, because each of them is diameter 1 inches and depth.
Well, no, they have to have different specifications because they have different orientations relative to the host part. But let me just make some general points. So the idea I have for the ontology is that you're going to have active drilling a hole, active. What's the word for creating a slot? What do you do to milling a slot? So you're drilling a hole and you're milling a slot. You have 2 acts, 2 instances, and they're both instances of the same type. And now the specification, for instance, with regard to the kind of plate, is that the plate?
Box plate,
Box.
depends on dimensions.
All right, so
you make it
have
flat.
2, actually I know how to solve the problem.
This will be plate. That will be plate.
Okay, good. So we have a relatively simple ontology specification, but then, a relatively simple ontology which we use to tag complex specification data. So we're talking about manufacturing processes here.
Yeah.
We have a process of milling a slot and we have a process of drilling a hole. We use act of milling and act of drilling to tag the data about where these processes take place. Now, I don't see a problem in that approach, and I don't see any additional problem created by this case as contrasted with the simplest possible case where we have 15 holes in one plate versus 15.
I think why I brought this, I think, is it because of, did we talk about operations, I think?
A little bit.
I wanted to say that, okay, so this is one operation on this left side and one operation on the right side.
Are you talking?
If they are done on the same machine, so this is done on machine 1, and this is done on machine
1 also.
Machine 1, and this is done on machine 1. That is, in this case, this is one operation. But if this is done on machine 1, and this is done on machine 2.
But you yourself, when defining the conditions for being in operation, said that the contents have to be the same. So drilling and painting are 2 different operations, even if the same machine does both the drilling and
content and resource. I didn't
results.
Resource. Resource being machine 1 and machine 2. So I don't think we have finished the meaning in IOF.
Yes.
We spent enough time on these details, and we cannot do that in this 1 hour phone Blue Engine course.
Yeah, good. All right, so I think that's a good place to stop.
Yeah. So my argument, this is one operation, and here I have 2 operations. Yeah, we can stop here.